Okay guys, today we're going to talk about inverse relations. Now an inverse relation is the set of ordered pairs obtained by exchanging the x-coordinates with the y-coordinates. Now that's all it is. We're going to take the x-coordinate and we're going to switch it with the y-coordinate. So x will become y and y will become x. This means that since x is paired with the domain and y is paired with the range, the domain and range will also switch. So for example, on number 1, they gave us a set of ordered pairs. Now we know that it's a set because of the fancy set brackets over here. So all we have to do is give them a set of ordered pairs in return. Now this first ordered pair is 4, 7, so I'm going to give them 7, 4. Now my second ordered pair is 6, 2, so I'm going to give them back 2, 6. They gave me 9, -1, so I'm going to give them -1, 9. They gave me 11, 3, so I'm going to give them 3, 11. And then I close it with a set bracket. So if they give me a set of ordered pairs, I give them a set of ordered pairs. And all we have to do is switch the x's and the y's. So what I'd like you to do is pause the video and do number 2 on your own. Okay, so hopefully you got the set of -9, -5, -6, -4, -4, -2, -3, 0, and then you close it with your set bracket. Okay, on number 3, 4, and 5, this time they didn't give us a set of ordered pairs, they gave us a table. So what we have to give them back is a table. So you guys have some room over here to the right to make your new table. But we need to make sure that we understand that this is our original table and this is our inverse table. So we're going to call it inverse, and then we're going to make an x column and a y column. And whatever was in my x column is now going to go to my y column, and whatever was in my y column is now going to go to my x column. So my first pairing was -8, -15, so now it's going to go to -15, -8. It was -2, -11, so now it's going to be -11, -2. It was going to be 1, -8, so now it's -8, 1. It was 5, 1, so now it's 1, 5, and it was 11, 8, so now it's 8, 11. Now notice the y column was -15, -11, -8, 1, 8, and now that's my x column, -15, -11, -8, 1, 8. Same thing with the x column, -8, -2, 1, 5, 11. Now it's the y column, -8, -2, 1, 5, 11. So knowing that information, that's going to help us make the inverse table on number 4. So again, we need to start by writing inverse, because we want to make sure that we understand that this is my inverse table, my inverse x and y value. And we're going to take what was my x column and make it my y column. So -8, -2, 2, 6, 8, that's going to come over here to my y column. -8, -2, 2, 6, 8. Then my y column, 3, 9, 13, 18, 19, that's going to come right over here. 3, 9, 13, 18, 19. Then just do a double check that they're paired up correctly. -8 and 3, -2 and 9, 2 and 13, 18 and 6, and 8 and 19. Alright, now what I'd like you to do is pause the video and do number 5 on your own. Alright, so you'll see here that I've got the x and the y column have been switched, and now it's 14, -6, 11, -5, 8, -4, 5, -3, and 2, -2. So when they give you a set of ordered pairs, you have to give them a set of ordered pairs. When they give you a table, you have to give them a table. On number 6, when they give you a graph, we have to give them a graph in return. Now it says, graph the inverse of each relation as a solid line. And then it says the graph of y equals x is already graphed as a dashed line. This is really important. We're going to talk about why that's important after we graph the inverse. So notice on the original line that they gave us 3 very prominent ordered pairs. So what I want you to do is start by making an x and y table. It doesn't have to be huge over there in the margin or in between the two graphs. Just make a small table so we can list these 3 ordered pairs. So my first ordered pair is at the point of 1 to -3, 1, 2, 3, 4. My second ordered pair is at 0, 3, and my third ordered pair is at 3, 2. So now that I have made an x and y table for my original line, that's when I want to change that and make an inverse x and y table so I can come up with the 3 new points for my new line. So if I say negative 3, 4, that's going to become 4, negative 3. 0, 3 will become 3, 0, and 3, 2 will become 2, 3. Now we can graph these 3 points and connect them with a line. So 4, negative 3 is going to be to the right, 4 down 3. 3, 0 is going to be to the right, 3 up 0. And 2, 3 is to the right, 2 up 3. Now get your straight edge and connect it all the way through. End it with arrows, and it should look like that. Now, if you'll notice, there we go, our 2 lines intersect directly, whoop, that's a little too big. Our 2 lines intersect directly on that dashed line of y equals x, and that has to happen every single time. Because if you'll notice, if you were to fold your paper down this dashed line, these 2 lines would lie directly on top of each other. That's what inverses are. They are reflections of one another over this line of y equals x. So this line of y equals x is given to you on each one of your graphs, and it's going to help you see if you graphed it correctly. So for example, on number 7, if your graph ends up looking like this, notice they don't cross each other on this dashed line, so that means you got it wrong. So let's try on number 7. First thing we need to do is we need to make an x and a y table for the line that they gave us. So this first point here is at negative 2, negative 3. Then we have negative 1, 0. And then we have 0, 3. Then I can come over here and make an inverse table. So it'll be negative 3, negative 2, 0, negative 1, and 3, 0. Now we plot our points. So negative 3, negative 2, 0, negative 1, and 3, 0. Get your straight edge, and we can connect it all the way through. And again, notice right here, it definitely crosses each other on the dashed line. This line looks exactly like this line, but over the dashed line, which means that we have done it correctly. So next, go ahead and pause the video and do number 8 on your own. So your 3 ordered pairs on the original line were negative 4, negative 4, 0, negative 1, and 4, 2. Then our inverse, when we switch it, would be negative 4, negative 4. Notice that's the same point. Negative 1, 0, and 2, 4. So when we graph it, they all intersect at that point right there on the graph, which is that negative 4, negative 4. Okay, next we want to talk about how to find the inverse of a function. Now remember, a function is just an equation where every element of the domain maps to exactly one element of the range. So on number 1, it says f of x equals 4x minus 3. I want to find the inverse of this function. This right here, f of x, is just function notation, and we're used to seeing y instead of that f of x. So there are 4 steps to writing the inverse of a function. Now these 4 steps are very logical. For example, the first step, we know we don't like to see f of x. We typically like to work with y instead of that. So the first step is really just to change that f of x to y and have our equation as y equals 4x minus 3. Now our second step is actually the true inverse step of finding the inverse of a function. Notice how on the set of ordered pairs, the table, and the graph, our whole process of finding the inverse was changing the x and the y value. So the second step here is to switch your x and your y value. So instead of y equals 4x minus 3, we're going to have x equals 4y minus 3. Now the third step is very logical as well. We don't like to see it like this. We typically like to see y all by itself. So next we just have to solve for y. So I'm going to add 3 to each side. And we'll get x plus 3 equals 4y. Then I'm going to divide each term by 4. and I'm left with 1/4 x plus 3/4 equals y. Now my final step is kind of a twofer. First of all, I don't like the y over here by itself, so I really want to put it in front. But I have to change it back to function notation. Now I can't write f of x equals 1/4 x plus 3/4 because f of x already is equal to the 4x minus 3. So instead of starting with f of x, I have to use this guy right here to show that it's inverse. And how we write that is f, and then I'm going to have a little exponent of -1, and then parentheses x. So we read this as f inverse of x equals, and then it's just whatever y is equal to, that 1/4 x plus 3/4. So our 4 steps: change f of x to y, switch your x and y, solve for y, and then put y back to f inverse of x. Let's try it again on number 2. So step 1, we want to change this f of x to y, so we'll have y equals -3x plus 7. Next, we switch our x and y, so x equals -3y plus 7. Then we solve for y, so subtract 7 from each side. We'll get x minus 7 equals -3y. Divide each term by -3, and I'm left with -1/3 x, negative over negative is a plus, 7/3 equals y. Now my final step is I need to change this y to f inverse of x. So I'm going to start with f inverse of x equals -1/3 x plus 7/3, and that's our final answer. So 4 steps to this process. Let's try it again on number 3. First, we're going to change f of x to y. So y equals 3/2 x, that's a 3. Y equals 3/2 x minus 8. Then we switch our x and y, so x equals 3/2 y minus 8. Then we can solve for y, and I have x plus 8 equals 3/2 y. Now just a friendly reminder, we never ever ever divide by fractions, so I don't want to sit here and divide each term by 2. Instead, I also don't want to multiply each term by the reciprocal of 2/3 because that leaves too much room for error. Instead, I want to get rid of the fraction by multiplying the entire equation by 2. And 2 times x gives me 2x. 2 times 8 gives me 16. 2 times 3/2 y gives me 3y. Then I can go through and divide each term by 3, and I'm left with 2/3 x plus 16/3 equals y. So to finish it out, we need to change that y to f inverse of x. So f inverse of x equals 2/3 x plus 16/3. Okay, the next one. We're going to start by switching this f of x with a y, so y equals 3x minus 1 over 6. Then we can switch x and y, so x equals 3y minus 1 over 6. Then we solve for y, so I want to get rid of this denominator. I'm going to multiply each side by 6, and that's going to leave me with 6x equals, now this 6 over here cancels out with the denominator and just leaves me with 3y minus 1. Add 1 to each side. Divide each term by 3, and I'm left with 2x plus 1/3 equals y. So my f inverse of x equals 2x plus 1/3. Alright, we're going to try it again on number 5. Change this f of x to y. Switch your x and y. Then solve for y. So we'll start by distributing. adding 15 to each side. Dividing each term by 3, and we're left with 1/3 x plus 5 equals y. So f inverse of x equals 1/3 x plus 5. Alright, one more. We're going to switch this f of x with a y, and we'll get y equals negative 15 minus 3/5 x. Switch your x and y, so x equals negative 15 minus 3/5 x, or excuse me, y. Then solve for y, so add 15 to each side. We get x plus 15 equals negative 3/5 y. Then I want to get rid of this fraction, so I'm going to multiply the whole equation by 5. Now 5 times x is 5x. 5 times 15 is 75. And 5 times negative 3/5 is a negative 3y. Then we can divide each term by negative 3. Now 5 divided by negative 3 is negative 5/3 x. 75 divided by negative 3 is a negative 25. And negative 3y divided by negative 3 is y. So I have f inverse of x equals negative 5/3 x minus 25. And that's all there is to it.